Hey guys, it's Chris here from the Ultimate Recycler. Welcome back to the channel. I'm in my messy shed and I have a repair job to do for a lady. She brought this into the shop and basically said, I hear you do repairs. I certainly don't advertise the fact. And why am I doing customer repair jobs when I have all these projects here that'll last me 3 or 4 lifetimes, plus unboxing and all the other series that I'm doing? Well, the answer to that's between me and my therapist. I like a challenge. I said I'd help her out. We may as well film it. It's a common problem. The wires where they come out of this charger are broken or shorting together. I'll give you a close-up in a minute. The charger suits an electric chair. Now, not one that you would strap someone to who you don't like. It's a massage chair, and it's actually 24 volts DC, which is a bit unusual. Otherwise, you know, I would have probably just sold her a new power pack because I have lots of them stashed away. I don't have one of these. Let's see if we can fix it. We'll have a closer look and work out a plan of attack. Now, wires sometimes get damaged on these things, whether it's an animal that chews them or it gets creased under a chair leg or something. But this one has an issue right where it comes out of that molded part. And I think you can see there, if I get it close enough and we stay in focus, it's actually broken both wires and it must have shorted together. So hopefully it hasn't damaged the actual power supply. But how we're going to fix it is, I'm not too sure yet, because this part here is quite solid. I think it's like vulcanized to the wire. I don't think the wire will just slip through it. And of course with these, they're not designed to be fixed. There's no screws. We can't take it apart easily. It's probably glued, and quite often you can give them a quick sharp tap and they will actually break open. I don't want to do any damage to it, so I'm trying to work out what the best plan of attack is. Now, I could probably cut with a knife. I could carefully cut down the side of this molding, but I don't know if we're going to be able to free up enough wire to resolder them back together and maybe put some heat shrink tubing on it. I'm not sure if it's actually kind of vulcanized to the wire or whether the wire will slip through it. I haven't worked that out yet. If we can open it easily, we might be best to unsolder the wire off the board, see if we can slide the remaining wire out of this fitting and perhaps push some fresh wire through. That will give us the best finish. Yeah, the cord's going to be like 1 inch or 2 shorter. That wouldn't make any difference. Otherwise, we're going to have to try and carve this away, join the wires, get some heat shrink tubing on there. It's going to look a bit messy and a bit of a dodgy repair. Even though I'm sure it'll be okay, I would like to do it as neat as possible. So my first thought is let's see if we can open the case. Some of them do fall apart very easily, and then we could just glue it back together. I certainly don't want to smash it. I think it'll give it a gentle hit for a start and just see what happens. So the big hammer, maybe the little hammer. I don't really want to fracture the plastic. I'm wondering if we could put some IPA around it and maybe soften the glue, but I have a feeling they're kind of clipped as well. And the times I've scrapped these, they do usually come apart very easily. So rather than trying to soak it in glue first, let's just give it a bit of a hit and see if anything happens. Okay, that feels pretty solid actually. All right, doesn't feel like we're going to get anywhere there. The towel's obviously cushioning it a lot. Let's try the bigger hammer, just to get a bit more area. Okay, not sure if we're getting anywhere. Okay, I don't want to hit it any harder than that. I might try some IPA. Oh, I might have actually moved it. Oh, look at that. It has. It's cracked the glue a little bit. Right. So I may be able to get a little watch back opening tool in there and just pry it open a bit more, but that's encouraging. I won't hit it anymore because I don't want to fracture it. This side hasn't moved, but we have made a start on that corner. All right, I think I might try some IPA first anyway. Let's just see if it opens. or how tight it is. Yeah, it's not going to click open very easily. I'm going to dribble some IPA around there, which is isopropyl alcohol, because I really want to know if it works, because sometimes if I can't crack them, at least I know if it does work on the glue they use, it'll get me into some of these things if I need to. So we'll try that first and see if it makes it any easier. Okay, let's dribble a fair bit around here. I'll put lots on because it evaporates pretty quick, and it's not going to harm the electronics inside. So hopefully this actually does dissolve the glue they use on these things. Okay, I don't know how long it'll take to dissolve it, if indeed it even does. Alright, I'll keep going with the IPA and just see. I really need to know if it does dissolve this glue. And I've got a pretty good feel for how tight it is at the moment. Maybe I need to leave it soak for quite a while. So I'll get back with you shortly. Okay, that's been soaking for quite a while, and I've applied more and it's just not freeing up at all. And the IPA would definitely be getting into where it would be glued, but I don't think it is glued. I think it's probably more of a vulcanizing process where they melt the two halves together. I don't think there's any glue in there for us to actually dissolve. So the only way to really get into it further is probably to go back to the hammer and just gently work around it, just to fracture the seam. Once we get it apart, we can clean it up and re-glue it or glue it. If I keep levering, I'm going to chew up all the edges. So I think just the shock treatment is the way to go. So I've had success. I just kept hammering gently with the towel and hammered on a little bit of an angle a few times, and it just seemed to break the join. I didn't hear any cracks, but I've noticed that it's now completely loose on both sides. So we should be able to now get into it. Oh, it's got shielding in there. Okay, so we haven't really damaged the casing, and we should be able to glue that back together quite nicely. Right, now, how are we going to get... Does the other side come off too? Looks like it does. There we go. Excellent. Now we're going to have to unwrap this shielding, but we can now see... Oh, there we go. We don't have to move very much because we can get to the wires on the end here. I'd rather not have to take all the tape off if I can help it. So let's see. Well, it slides. Oh, there we go. Beautiful. So we can get to the two wires now where they're soldered on the board. We still haven't proved that the power supply is okay because this is shorted out, so it may have blown a fuse. Hopefully it hasn't done any other damage. I'm going to desolder these wires. Then I can actually plug it in. I don't have to put it back in the case. And we can make sure that we have voltage, our 24 volts at this end. I don't want to plug it in now because it'll be a direct short. Oh, it looks like one of those wires is actually broken, nearly broken clean off there. Right, so we'll disconnect this and then we'll look at how we're going to go about fixing the wiring. Okay, I'm going to start by adding a bit of solder to both of these terminals. A bit of fresh solder. Okay, it's nice that the circuit board slides out a bit from that housing. I don't have to untape anything or remove any of the heat, any of the shielding. Okay, that should be nearly enough. Now I did note that one of these wires has a little bit of white tracing on it, which is probably the positive, and it goes to the inside. I think we'll just be able to pull that one through now. Yep. It's got a bit of glue on it, that won't hurt. And this other one will be the negative. And a lot of glue on that one. Or we might have to clean a bit of the glue up just to get the wires back in. But now at least we can plug it in and see if we have voltage there. Okay, mains cord's plugged in. We'll turn it on. It's through my dim bulb tester just to make sure there's no shorts or anything badly wrong with it. Okay, so it didn't light up the globe, which is good. We don't have any smoke, which is good as well. Let's go to, we'll have to go to the 200 range. Should be 24 volts. And I think negative is the outside. No, we don't appear to have any voltage. Maybe it has blown a fuse. Okay, we better see if we've got voltage going in, just in case something's going on. I'm going to have to slide this right out. I can do that, I think. I'm going to turn it off first, though. All right, let's slide all this shielding out of the road. And we'll have a look in here. There's a lot of glue around the place, as they tend to put on these things. Can't even see where the fuse is. There's a little LED globe there. I didn't notice if that was going or not, but then we had the shielding over it. I guess we can turn it back on now and see if that lights up. Okay, we now have no green LED, so it's possibly blown the main fuse. I've just got to find where the fuse is. Oh, it's possibly in here. Let's turn it off again. Put our meter to the buzzer. And let's see if we have continuity through the fuse. Yes, we do. So the main fuse is okay. Does it have a fuse on the secondary side? Just doing a few checks. I've got 240 volts AC coming in from the mains cable. Now on the main capacitor here, we should have a very high DC voltage. So I've switched my meter to DC, and very carefully, without shorting the terminals on the heatsink here, we have 310 volts DC. I think that's okay. So I think the hot side of this power supply is all right. We don't have any power coming out the secondary, and I can't see a fuse. It may have blown a diode. Surely there'd be some sort of protection from short, because all that's happened is these two wires have actually shorted. So I would have thought a power supply will have some sort of protection. I can't see a fuse, but everything's jammed in together. So I'm going to turn it off again and have a really good poke around. Might just test a couple of diodes. But yeah, I'm hoping to find a fuse that's blown. That would be easy. Okay, I really didn't want to go down a rabbit hole with this repair. I certainly didn't want to spend much time on it, but it's, as usual, it's turned out more complicated than just a broken wire. I suspect that the MOSFET in here, or voltage regulator, or whatever it is, I'm not sure, but it's got 3 legs on it, and I'm getting a short between both outer legs, both directions. I don't think that's normal. I'd need to pull it out, see what the part actually is, and see how to test it properly. So that's my next attempt. There's no fuses in here, and I've just checked basic things like make sure capacitors or diodes aren't shorted. I'm pretty sure it's in the secondary circuit here. The hot side seems okay. The main capacitor had good voltage, and when I powered it off, I shorted it out, and it had quite a punch in there still. So I'm sure the main side's okay, but because the LED is not lighting up on the secondary side, we've got some sort of problem, and I don't think it's a capacitor or a resistor. So I'm going to pull this MOSFET or whatever it is out and have a look and just see if I can work out what it is and whether it actually is blown. I don't really want to buy a new part for it, but I've got a few of these power supplies shoved aside. Hopefully we can find one with the same number and swap it out, but we'll pull it out first and test it and see if it's any good. Okay, I got this component off and it tests fine. It's actually a diode array, or it's a rectifier. It's basically a double diode, if you can see the symbol on there, and it tests fine. So I took the shielding off from around the side to give me a bit more room to look at things. It was just one tab to take that off. And I've found a problem that I've caused. Well, actually my hammer has caused. So hopefully that's all the issue is, and I might be able to fix it, because this transformer isn't actually glued to the board. It's a little loose. It's only got wires this side, but it is mounted through hole into the circuit board on this side. And when I was looking around just to see if there was any bad solder joints or anything like that. I found some, but they're actually physical damage. Now I'm not sure we're going to see here, but this spot here, the actual terminal has lifted off the circuit board and it's pulled the trace off with it. So the hammering has jolted some of the parts, and this area here, I'm going to have to resolder it because it may have broken the copper traces. We can get a focus here. Yeah, that's the worst one there. You can see it's actually lifted the trace off the board. So hammering isn't necessarily a good thing. Hammers and electronics aren't, probably, natural enemies. Certainly in most scrappers' eyes, they're meant to break things up, but in this case, I didn't want to damage the board. So I'm going to resolder all those spots where they've lifted a little bit. I don't think it's done any other damage, and hopefully that's all our issue is, because that center transformer separates the hot side of the board, which I think is okay, from the secondary. And if one of these terminals isn't working or isn't connecting on the transformer, that would leave us with no power on the secondary. So that's the theory. I'm going to resolder those parts. I'll have to put that rectifier back in and we'll give it another test. Now to resolder things. There we go. So I guess we're ready for a test. I'll just do that screw up a bit tighter on that rectifier. Okay, we'll turn on the oscillation transformer and hopefully nothing goes bang. Very good, we have power. Hopefully we have an output voltage this time. Let's get the meter back in shot. And we're now going to need, go to the 200 scale, DC. And let's see how we go. Oh, beautiful, 24 volts, excellent. So there we go. I fixed the problem that I made inadvertently, but it would be much nicer if manufacturers just put screws in the casings and you could get into them and fix them. All right, so we know that works. I now have to figure the initial problem and try and sort this out. I'd like to still be able to use that molding, but whether we can get the wire out from inside it, I'm not sure. So just having a good look at this, the wires are essentially bonded. I don't think I'm going to get them through. Doesn't look like they're going to slide through easy anyway. Oh, maybe they might. I'm going to cut one end and see if I can drag them through. If I can't, I'll cut them both off and try and get a drill bit through just to make a bit of a better hole, because I would like to use that rubber molding, and it's also got a square section that locks into the case, so I kind of want to use it. So let's snip, oh, we won't snip those off, we'll snip these ones off. Oh, that one's broken anyway. Oops, I might have gone out of shot a bit there, sorry. And we'll see if we can haul them through somehow. Yeah, they're certainly not meant to slide out, but... oh, okay. We might get the copper center part out, but I don't think the insulation's going to come. Still, if we can get the copper out, we might be able to run a fine drill bit through there and open them out a bit. Alright, so the copper does come through, but we only have two fine holes. Alright, I wonder if I can work a drill bit through there carefully. Okay, I've moved back out to the other bench. There's a bit more room to work here and a bit more room for the camera. Now, I wonder if this is going to work. Not sure how soft the rubber is. I don't really want to poke it out the side. Oh, it might be working. We'll go from each end and see if we can meet in the middle. It's difficult because it's got two holes to follow. No, I think it'll work if I persist. I don't really want to drill a hole in my finger either. I think it's going to follow one of the holes. Now that won't matter as long as we don't come out the side. Alright, I'll muck around for a bit and I'll see if I can get it big enough to get the wire through. So I've managed to get a drill bit right through it. I think it poked through the side there in one spot, but it won't matter because it's well in... I mean, the wire's insulated anyway, so it won't matter at all. I really just wanted this outer flex part. So that pushes through fairly easy now. I wonder if I can get the wire through there. So we just about got it through, I think. It's quite firm and I've got to wriggle it to gain a bit, but come on, last bit. Yay! The wires have come through and they're very firm. That's beautiful. Fantastic. Alright, now I just have to trim the ends of the wires up, solder them onto the board, the correct polarity, and Bob's your uncle. Assembly has gone well and I've tested it and we have 24 volts at the plug. I'm just going to put some hot glue in here. It was glued initially. I don't think it's necessary, but I feel it is necessary now that the wire can slip through this boot. We kind of need a bit of glue on the back of it as a strain relief so that if the cord gets a tug, it can't slip through and pull the wires off the circuit board. So I think that will do it. We don't need a lot. I think most of these parts are glued on these boards for when they're assembled in the factory, and it stops the components falling off the board when they're automatically soldered, however the process works. So I don't think the glue is necessary for any insulation or any part of the actual electronics. Okay, so that should be fine to reassemble. I've just cleaned up any burrs along the edge of the case, but it wasn't too bad. And we should be, I'll have to slide the shield back over so the LED lines up with this little hole. And we've got a little square section on this boot. To drop into the casing. I think it goes that way. Yeah, that locates there. Now we can put, yeah, oh well, we've got to run some glue. I'm just going to use super glue around the outside. I might take the plug out of this end. And make sure that's seated home. Yep, that should be pretty good. Get this string of glue off here. Alright, I'll run some super glue around the edge. We'll press the case together. And I think we're finished. It clipped together nicely. We'll clean the extra glue off. We can tidy that up with a bit of acetone, I think, later. We're just going to make sure it's seated and it's going to stay together. And we'll give it one final test, but it worked perfectly before, so we should be right. I guess we'll make sure the green LED comes on. I didn't notice that before. Okay, that's glued nicely. I'll just clean any residue out with a bit of acetone. We want to leave as neat a job as we can. But really, you'd be hard-pressed to know that anyone's actually been into this. Oh, takes the black off too. I guess we've got to be careful with that. It's probably the paint finish. Alright, so someone's probably going to know we're into it now. But I think it's got all the glue residue off. So let's turn it on and see if our little LED lights up. There we go. Beautiful. So all repaired, as good as new as far as strength goes. You wouldn't know that that's actually been repaired. And you've still got the structure of this boot to protect the wire from flexing too much right at the edge, which is what the boot's for. I'm not sure how it got damaged right there, but anyway, it's repaired. And there we go, guys, the repair job done. Probably turned out a little more complicated from my own doing, as you saw. What have I learnt from this? Well, I think just about all these power supplies, I suspect, are not glued. I know I did an iPhone charger or something ages ago, and I had awful trouble getting into it as well. So there's some sort of hot or cold vulcanizing of the plastic shells to seal them together. They don't want you to get into them, unfortunately. But I think next time I will try the hammer, but with a blunt chisel, so that I can just gently fracture the join rather than hitting flat on the whole side, because the jolts, as you saw, moved that big transformer, which caused the damage to the circuit board. I think if I just used a blunt chisel to crack the seam, we probably wouldn't have to give it so much violence. That's what I'm going to try next anyway. At least this one was a bit unusual, with that transformer having wires out one side and it was only attached via pins on the other side. The transformer wasn't glued. They glued nearly everything else. So because it was fairly free to wobble, probably did the damage. Perhaps if the transformer was attached more securely, I wouldn't have had that issue. Anyway, I've learnt something. We've fixed the job, so it's a win all round. I'm sure the lady's going to be happy. So yeah, beauty. Another repair job successfully done. Thanks for watching, guys. We'll catch you in the next video. Bye for now.